Trees in every country. Trees, you know we can work together and learn what we need to meet the challenge.
Hello, and welcome to the Conference Rewind video series. I'm Luana Vargas, and I serve our industry as ISA's Director of Credentialing Services. Today, we're happy to share a presentation by Dr. Linda Chalker-Scott on landscape soil testing. This presentation was originally done for the ISA 2021 virtual conference, and the views are those of the presenter. We invite you to sit and learn from our speaker on this topic today.
Hi, my name is Dr. Linda Chalker-Scott. I'm a professor of horticulture at Washington State University and also an extension specialist in urban horticulture. And many of you have heard me before, and this is actually a new talk for me on landscape soil tests and what we really need to get out of them in terms of useful information for our clients. So just as a quick overview, and I will tell you that there is a handout for this as well, which you'll find very useful, as it has many links. We're going to start just talking about what the goal is of managing particular landscapes. And this is important because of how it influences soil tests and especially soil test interpretations by the company. Then we'll look at the different methods for testing soil and the criteria we need to think about. We will discuss interpreting the results, at least the ones that are important for us to use in management. Then, and a very important part of using soil test results is to ground truth them before you take any steps, and we'll discuss that. And then finally, I have some tips or advice that you can share with your clients in terms of landscape management. And this is a relatively short talk, so you'll understand that I'm only touching on some of these things. The handout goes into a little bit more detail. So there are three types of landscapes we're going to consider here, and we have to consider that the goals is going to determine what, or the goals are going to determine the type of management. And the one thing that we're not going to do is talk about managing crop fields, monocultural crop fields. And I mentioned this, I mean, it's all obvious to us, but it's important to understand that when soil tests first came out as being a thing, it was geared towards managing crops. We also have systems that are kind of like crop fields, but are a little bit more diverse. And these would be similar to home gardens. And then finally, we have landscapes, which is what most of us are dealing with. But these three things are important to look at because you can see the continuum of what the goals are for all three of these systems. So these differences I'm going to discuss, this is on the handout, so you don't have to worry about writing all of this down. But we've got three different systems. We've got the intensive agriculture, then the home vegetable garden, and ornamental landscapes. And there's several criteria here to consider. The ones we're going to focus on, of course, have more to do with nutrients and soil testing than anything else. But it's important just to see how these different criteria are going to determine how you're going to manage things. And the important points for this talk are that the nutrient inputs in intensive agriculture are high by design. They have to be, because the goal of intensive agriculture is maximizing yield. In contrast, the nutrient inputs into ornamental landscapes is low because many of those nutrients are recycled. And the goal of an ornamental landscape is sustainability. In other words, you're not having to manage it constantly by adding things and taking things away. So just seeing these differences and understanding that many soil tests are geared towards the intensive agriculture is going to help you not only in selecting labs, but interpreting results. So the criteria we're going to discuss are going to be specific, of course, for whatever landscape you're testing, but I have a really good suggestion. I've never seen this done before, and it's something that I will start recommending more. And this is to have a control system. And so you know that in an experiment, you have a control and you have a treatment. This is kind of the same thing. But what this does is it allows you to see what the natural conditions are for your location. So in other words, if you're managing a city park and you're managing trees there, you know, find some other location in the same general area that has a forest system that's relatively untouched. In other words, there aren't housing developments there, but it's pretty much just a forest system. That's going to be your control. And finding out what's natural and normal for your area is really important because your particular system may not reflect this. So there are some tests you can do on your own, which is good because that way you don't have to pay for it. The easiest one to do that many of you may be familiar with is the texture test. And on the handout, I have a hot link that goes to this particular gentleman. This is Dr. Craig Cogger, my colleague at Washington State University. He's a soil scientist, and he has a really nice, no pun intended, hands-on demonstration on how to test for texture. You can also test for compaction, and you can test drainage. And the details for those are more extensive than we have time to go into, but they don't require a whole lot of special equipment. So they are relatively easy to do on your own, and they are much cheaper than sending off soil. And in some cases, you really can't send off soil to test for things like compaction. In terms of lab tests, you want to choose the right lab. And I have some personal experience in choosing the right labs and choosing the wrong labs. In general, if you choose a government lab or a university lab, you're going to be assured that you are only getting information and you are not getting a sales pitch. And I have seen results from many labs, not many labs perhaps, but several labs that are commercial labs that then come with a long list of proprietary products that you're supposed to buy to address all of the problems that this lab will tell you have. That's not what you want. You want unbiased information that's going to come along with some good recommendations. The second thing to think about when you're choosing a lab is making sure that that lab is used to working with soil samples outside of intensive agriculture. If you don't, if you end up going with an agricultural lab, you are going to get recommendations for managing crops. And that's not going to be the right thing for you managing your trees. Then there's the methodology, and most labs, especially the university and the government labs, will have an online site that will explain to you how to do soil collection, but I'll just mention it briefly because it is important. You're going to want to collect more than one sample from your particular test location. And that doesn't mean that you're send in several samples. It means that you're going to combine them. So let's say you're working on a series of street trees. You would go through, you would move aside any mulch, you would do your sampling per the instructions on the website, and you would maybe collect 5 or 10 different samples. And then you're going to mix them all together and create a pool. And then you're going to take one sample from that. And that way, you're pretty much assured of testing, the soil relatively completely and not having accidentally gotten into some part of that site that may be different than the rest of it. So this is a way that you ensure that you have a good mixture of the soils that are on your site. Now, if you're doing more than one site, of course, you have to have different samples and different pools because those are going to be probably different from one another, or maybe not, but it's important that you have those things separate. How often do you do this? Well, that's going to depend on your test results, which we will discuss. You'll need to do it obviously at least once, and I recommend this to anyone who's managing any type of system that you've got to have a baseline test. And there really is no reason not to get one now, because you can get good results that don't cost very much, and it makes a huge difference to know what you actually have in your soil rather than just making guesses. Depending on the lab you use, you're going to have some options. And so obviously you're going to have the tests that are going to test all of your essential nutrients, and that's the standard. And then depending on the lab, there are some additional tests, or they may be part of the regular testing, but I really recommend, if your lab only is testing nutrients, that you also have organic matter tested. This really is crucial for figuring out any deficiency problems or any excessive nutrient problems, as you've got to have that organic matter. And you can make some interesting inferences by looking at the organic matter and your nutrient levels. If you happen to be someplace that heavy metals would be of concern, let's say you're doing restoration in a previously industrial site or something like that. If there's any possibility that there are heavy metals of concern for human health, you want to ask for those tests. And finally, if you happen to be in an arid part of the world where rainfall is pretty limited, or if you're in an area that you're concerned about de-icing salts, you'll also want to have a soluble salt test. And again, if you're going to do this and really get the most information out of it, you also need to send a sample from a natural area, so you have that control that hopefully you're going to shoot for. That should probably be your ideal in terms of the conditions there. So now this is the part that will may be controversial, but in terms of being a practicing arborist and thinking about entire systems, this is the information that's really important to focus on. You want to look at excessive nutrient levels, and you will find those commonly in urban areas. And depending on who your client is, if it's a private residence, I can guarantee you're going to have some excesses. If it's in a public area, perhaps not. But you're going to want to look at those excessive nutrient levels. The reason is that when you have too much of something, it gets reported as being above optimal. I prefer the word toxic, because when you have more than the needed, it's going to start interfering with nutrient balance. And you can have toxic effects on the plant just because you have too much of one thing that's interfering with the ability of the plant to take up something else. Then you need to be able to identify the sources of these nutrients. And this will obviously require some discussion with the client, or if you're the person who's doing the management, looking at your historical records to figure out where are these nutrients coming from. You also want to have the soil organic matter, and you're going to be focusing on that and answering some questions about it that the test won't show, but things that you should be able to figure out either from your own history or from your client's history. Understand that the optimal organic matter is not a set number. It is going to vary depending on your site. And that's also pretty controversial, because we've been told forever that the ideal amount of organic matter in a soil is 5 to 10%. And soil scientists don't say that anymore. And there's now evidence that you can find just from soil tests that will show you it's not true. So this will be specific for your site, and hopefully will match up with what your comparison system is. The nice thing about understanding your soil organic material is it will directly correlate with nutrient levels. This may seem obvious, and it kind of is, but it's important to think about it to explain to your clients. So in other words, if you have low nutrients in the soil, if you're showing deficient levels, that means you have low organic matter. If you have optimal nutrients, everything's pretty much in the optimal range, that means you have ideal organic matter for your system. And this is the important thing to remember, that ideal is going to vary depending on your particular site. And then if you have too many nutrients, it can mean that you have too much organic matter. It can also mean that fertilizers get overused. But if you have high organic matter, depending on the type of organic matter, it can lead to excessive nutrients. So most common nutrients that you'll find in your sites as being excessive, in other words, over optimal levels, are things like phosphate, things like magnesium, which is what Epsom salts is, that's magnesium sulfate, and things like calcium. So these are criteria that you'll see in the tests I show you that are often high, and the reason is because especially our clients who are private homeowners tend to overuse fertilizers because they're told they should. And a lot of that telling is because of what we've done historically with growing intensive crops. But when you're growing crops intensively, it's not the same thing, again, as maintaining a landscape. So now the fun part is correlating the organic matter in your soil system to those nutrients. So here's a test. And this one is actually from University of Massachusetts at Amherst, which is my particular favorite place to send things. And a lot of people will say, well, that's not your system, because as you'll see here, it'll tell you that obviously this is extractions are done for New England soils. Well, it doesn't really matter, because especially if you have a comparative test done on a natural soil system, it really doesn't matter what tests are being used to analyze your soil. It's going to be comparable regardless of the tests that are used. But anyway, what I want you to see from this is that we've got an organic percentage of 8.7%. We also have nutrients that are all off scale. So, and it even tells you here phosphorus is excessive, which tends to be a real problem in terms of excessive levels. So this, again, although they call this above optimum, I kind of prefer the word toxic because it is much more descriptive of what this can do to plants in these soils. So for this system, And because I know the person this came from, I know that this person didn't use traditional fertilizers, but uses a lot of compost. So compost is a nutrient-rich organic matter. And so for this system, 8.7% of rich organic matter is too high, okay, because all the nutrients are off scale. So the recommendation here would be you've got to stop using that rich organic matter. Okay, now we're going to compare this to some place where we've got optimal nutrients. You'll see here that everything except for phosphorus is optimal. The potassium is optimal, calcium is optimal, magnesium is optimal. Phosphorus is a little bit low, and you can go over here in the left-hand column and you can see the actual numbers. But look what the organic matter is. It's 12.8%. Now, 2 years ago, I would have told you that 12.8% was too high because you still get set in that you're still stuck in the mindset that 5 to 10% is optimal, and it's not. It depends on the site, and it depends on the nutrient load. So because we have optimal levels here, and because this happens to be my own landscape soil, and I know very well how it's been managed over the 50 years we've owned the property, and have a pretty good idea of what happened hundreds of years before then, I can tell you that 12.8% organic matter is ideal for this system. And the reason it's ideal is because I'm in a landscape that is full of Gary oak trees. It's Quercus garryana. It's a white oak. It has very tough leaves that take a long time to break down. And centuries worth of oak leaves incorporated into the soil has resulted in a high organic matter. But this is not rich organic matter. It's slow to degrade. It doesn't create a huge nutrient load. So this chart shows you that you can correlate these things and you get a better idea of what the soil organic matter should be based on your site's historical conditions. And this takes me then to the diagram of the pie chart that we're all used to in terms of what ideal soil looks like. And we know that about half of it's solid and the other half is full of holes, and some of those holes are small. They hold the water, and the larger holes hold air. And what's missing from the pie that you're used to seeing is that slice that's organic matter. And again, it's because the organic matter is variable depending on the site. So this has nothing to do with what's on top of the soil, but actually what's incorporated into it. So there is not an ideal amount of organic matter incorporated in the soil. It's all dependent on that soil system and on the plants that are there. So the lab information that we're going to focus on to continue is things like the cation exchange capacity. And this is only important to look at if it's lower than about 5 milliequivalents per 100 grams. What that means is your soil is not hanging on to nutrients, and so you're going to have nutrient leaching. This is typical for low organic soils. It's typical for sandy soils. And so this is where you're going to want to take some action if it is low. You want to look at the non-essential heavy metals, any of those metals of concern, including ones that are typically reported on a soil test, like aluminum, which is not a heavy metal, but it still has the same types of impacts that heavy metals do. Things that might be of concern, lead, even though we don't have leaded gasoline anymore, nor lead-based paints. Once that element is in the landscape, it's there for good. There is no way to get rid of it, and it'll change its forms, but it'll always be lead. The other one to consider, depending on where you live, is arsenic, both because it's an industrial pollutant and was a component of many older pesticides. So these are two of the things you can get soil tests for. You can find out if you have levels that are above what's recommended. And it's not because we're going to be eating the plants that come out of here. The reason is because these metals are in the soil. And when the soil is disturbed, they get into the air. If you're handling the soil and you happen to put your hands in your mouth, they get into your mouth. And so the incorporation of these heavy metals into humans doesn't tend to be necessary through food that's growing on that soil. It tends to be by breathing it in or by getting it on our hands and then putting our hands in our mouths. So knowing those risks might, especially if you're a manager, would encourage you to have your crew wear gloves and masks so that they avoid contact. High levels of soluble salts. Again, if you're in arid regions or in de-icing areas where de-icers are used in the wintertime, If these are high, again, it will be a comparison. You'll know you need to do something about that because salt damage to trees is pretty classic, especially in de-icing situations. The things you don't have to worry about, best part, you don't have to worry about your pH. Your pH is what it is. You can't change it, you shouldn't try. You just have to recognize that that's what your pH is. If you have low to optimal levels of nutrients, you normally don't need to worry about it. If it's deficient, that's one thing, but if it's low, you're going to ground truth to see if you see symptoms of deficiencies. You don't have to worry about base saturation. There is no ideal value. It's just one of those numbers that tends to confuse people when they see it, and you can just safely leave it alone. Don't worry about the generic fertilizer applications. Again, this is kind of a holdover from production, and we are not in production. We are in management of a sustainable landscape, so you can ignore those. You can ignore anything about humus, humic acid, fulvic acid levels. They don't exist in nature. It's an artifact created during lab extraction process using highly alkaline reagents, and it's nothing that is created in nature. So again, something you can ignore. And this is going to show you why pH doesn't matter. Okay, so again, this is my landscape, and I'm actually standing right here right now at my home desk. And what I want you to see here is I have a variety of different plants. You can't see the Gary oaks, which are behind me, but we've got hemlocks, we've got a wisteria, we have viburnum, we have rhododendrons, we have azaleas, we've got lily of the valley. Now, if you look up on the internet to find out what the pH range is for all these trees and shrubs, you're going to find all kinds of different numbers. And the fact is, our soil is 4.9, which some of those sites are going to tell you, well, you can't grow viburnums in 4.9 pH soil. Well, yes, we can, because we are not doing something in a vacuum. This is not a soil that has a pH of 4.9 and no microbes or anything else. And a plant. And a lot of these times, the pH ranges are determined by very artificial lab conditions. If things are doing well in your landscape, it doesn't matter what the pH is. And if, as I said, you can find ranges all over the place from relatively acid to relatively basic. And you can't change it. Just recognize what it is and don't worry about it. Things you do need to worry about. Here's a test from our excessive site, and you can see there are certain things we're going to worry about and certain things that we're not. So we're not going to worry about the pH, as I just told you. It doesn't matter what it is, you can't change it anyway. We are going to worry about the excessive levels of all these macronutrients, which have numbers here. We have correlated that with a rich organic matter, and we need to stop using the organic matter, or to use organic matter that is so rich where the nutrients aren't as available. So that's the action one would take here to address all of these above optimal levels. For the one for the optimal levels, my own soil, pH doesn't matter. It is what it is. The organic matter is not a rich organic matter. It's slow to break down. And so its high level is not a worry. I ground truth the phosphorus issue. It says it's slightly low, but I have absolutely no indication of any phosphorus deficiencies in any of the plants. The one thing that is a concern is that the aluminum is quite high. And this isn't from any type of addition that we've done. This is just something that's natural for this particular soil. So it's something where I would be cautious. I should be cautious about handling the soil and putting it in my mouth and things like that because the aluminum is pretty high. So all these other things that are here that we mentioned, don't need to worry about them. These are the things we're going to worry about. So then we're going to move on to ground truthing. So we need to look at things that aren't in the lab tests, but things that can impair soil function. If you have a layered soil, you're going to have issues with water and oxygen movement. If you have an amended soil, you're going to have issues with water and oxygen movement. If you have a compacted soil, you will have low levels of water and oxygen in the soil because all the pore space has been squashed away. And if you have sheet mulched soils, things that are mulched with things like landscape fabric, you're going to have poor water and oxygen movement. These things aren't tested through your soil test, but they are going to affect root growth and tree health because roots need oxygen. And if you don't have that porosity, you don't have that oxygenation, you're going to have problems. They're not associated with nutrients. You're going to look for evidence of deficiencies. Okay, so if you have symptoms like this is classic iron or manganese deficiency. It happens to be in a rhododendron. So yes, we have a symptom here. But then we're going to look at that compared to what the soil test says. And the soil test says here that iron is quite fine. And manganese is also quite fine, right above there. So these are within the optimal range. So we know that this is not because the soil is deficient. We know that it's because the phosphorus in this particular test is excessive. So you want to look for evidence of deficiencies and then ground truth it with what your soil test shows. And if your soil test doesn't say that you've got a deficiency problem, then you should look at toxicities or those other problems, as I mentioned, in terms of soil function. So the types of things I suggest that we tell our clients is that we want to use database management. We want to have at least one soil test before we make any major changes. Well, we should have one anyway, but especially before a new installation, to have a soil test. We need to compare that to natural conditions as a control. We need to have baseline values for nutrients and organic matter, and then we can see what happens over time. If you have problems to address, you're going to be doing the test more frequently than if you don't. And then we select plants that tolerate soil and climate conditions. And having these numbers in terms of what the normal conditions are will help in selecting the right plants. And then being sure we consider the root requirements, the water, the nutrients, and oxygen. And everybody forgets about the oxygen. Keep in mind that sand is going to have very few nutrients. It's well aerated, however. Silt has few nutrients. It doesn't have as much water and oxygen, but it's a smaller porosity, so it tends not to move through as quickly. Clay is high nutrient, but low, least oxygen, because it's there's such small particles and they are plate-like, so they interfere with oxygenation oftentimes. Use your soil test to guide fertilizer use. So here they are in comparison again, the optimal versus the excessive, and know that the optimum can be correlated with, and excessive can be correlated with the soil organic matter. And then find out what's being used as soil organic matter, especially in the case of the excessive, and reduce it. And if it's no correlation with that, then it's time to look at fertilizing and what's been done. Keep in mind, roots need water and nutrients, oxygen, and microbial partners. And this is what a lot of tests don't take into consideration, because the microbes are important, especially the mycorrhizae, at helping to acidify the area around the roots and make things soluble and take them up. And so this is one of the reasons why the lab test for pH is relatively unimportant, because you're looking at it out of context, and in context you've got these microbial partners that are going to assist in nutrient take-up. Don't amend the soil ever, and that means working things into the soil, not top dressing. This is going to include things like inorganic matter, sand, organic matter, soil conditioners, packaged microbes, fertilizer, hydrogels, or biostimulants. Don't add anything. Just put the roots in and water, and that's all that really belongs there. The nutrient sources, if you have deficiencies, and you have to, that's a big if, then add whichever nutrient is required and nothing else. It could be fertilizer, it could be rich organic material. It doesn't matter as long as you know what you were trying to change. Don't add anything if you have a nutrient that contains nutrients that are in excess. So if you have excess, like the soil test has showed you, where almost everything is excessive, don't add anything. That includes fertilizer and compost. And then anything you do add, you're going to put on the soil surface, and you're going to cover it up with a woody mulch. Which leads to the last point, which is so important for trees, is that you want to use an arborist wood chip mulch. It's going to provide nutrients and organic matter, and it's going to protect and enhance soil ecosystems health. This is what's going to make your roots functional. This is what's going to make nutrients available on a slowly released basis. This is going to be what leads to a sustainable landscape.
Trees in every country, trees, you know we can work together and learn what we need to meet the challenge.